This is our instrument for getting us by the shortest possible route from point S, which is 4, 5, 6, to plane E. Plane E is defined in this formula, and here is a very simple sketch showing point S and plane E. Now, points A, B, and C are all in plane E. Vector -6, -5, and 1 was obtained from these points A, B, and C as follows. We call this vector a normal vector. And we have normal vector is equal to the cross product of vectors AC and AB. And so we have a normal vector, a vector normal to plane E, -6, -5, and 1. Now we can add a few things to our original basic sketch. Here we have S, which we saw before, plane E. Now we've got A, B, and C, which are points which define plane E. And H we call the line that takes us from S down to E. Notice, en passant, the similarity between the two expressions, one for the plane E and the other for the vector normal to it. Well then, back to our original instruments. Notice that 4, 5, and 6 again is point S, and that -6, -5, 1 is a vector normal to plane E. We've got to find out what R is, and we do that as follows. Well, there we are. Now we put these into the expressions for the plane E in order to find out what R is. And we work it through, and we end up with a value for R which is 11 upon 31. So now we can fill in and complete the expression for H, the line which takes us, if you remember, from S down to plane E. And we wind up with these values. X1 is 58 upon 31, X2 is 100 upon 31, and X3 is 197 upon 31. And these three are the coordinates of the point at which straight line H hits E. And here is a very basic sketch showing that. We have point S up there, we have the line H going down hits E at 58 over 31, 100 upon 31, and 197 upon 31. Finally, the distance from S to X is found as follows. And this, finally, this number, 11 upon 31 times the square root of 62, is the distance from point S to plane E.